So we're here at Open Source where a whole bunch of nerds show off all the cool projects they built, and today we're here with
Engineezy and my Marble Pixel jacket. This is the latest in technology of wearable Marble Pixel display.
Right.
The way it works is it pumps marbles up to the top from the bottom here, figures out what color marble, and then dumps it into the grid to create a pattern. Right now there's a checkered pattern going on. There's 10 patterns programmed into this thing.
Insane.
And the way it works is if it needs a color marble, but it's not there, it will dump a marble down the chute and then pump up new marbles to try to find the color that it needs.
So it's lifting them up randomly and then deciding what's the sensor, how does it determine which color?
So there's just a simple IR sensor here, like the cheap ones that you can get from Amazon, which they work actually quite great because we're just using black and white marbles. White marbles are very reflective, black marbles absorb all the IR, so it knows exactly what color is in the sensor.
And there are sensors that can sense specific colors if you wanted RGB or something, right? But IR is just cheap and easy. Binary, the number's high or low.
Exactly. And because we're only using two colors, it's like just the easiest, it's also the fastest way to do it because a color sensor requires time to figure out what color it is. An IR sensor is instantaneous, pretty much.
Right, and what's the mechanism to lift them from the bottom all the way to the top?
So in the bottom here, there's an auger, and basically this motor spins the auger, which pushes the marbles through the bottom of here, up the tube, and then into the sensor.
And the pressure comes from the bottom of the stack, and it's just marbles pushing other marbles.
Exactly, and like they're not very heavy, so it doesn't require a lot of force.
Incredible. And then while you were building this, and I know you've made other marble sorting machines, what's the hardest engineering problem that kind of kept you up at night while trying to build this and get this all working?
Interestingly, the hardest problem is because the marbles are so small and you want the image to look good, you need them packed as tight as possible together, which means that the thickness of the walls in between the feed-in pipes are really thin. And you can only print so thin with like standard FDM machines.
And when you want somebody to wear it on their back and not fall apart.
Exactly, exactly. And so that's the biggest challenge, really. Otherwise, like the gates are quite simple, the sensors are quite simple, the augers are like relatively simple. It's just single part moving against the motor. So,
do you ever have more than one ball in the stack at once, or do you do it so one ball has already determined its path, then you reconfigure it?
Right now it's just one ball at a time. Honestly, the code, I'm not a great coder, so there's room for optimization on the code here, but generally speaking, it's working better than I could have expected. And I only started this a week ago, so it's kind of a crazy project to take on for one single week. But
and if people want to see more about this and all the other crazy stuff they build, where can they find you?
Engineezy. Engineezy on any platform.
Sick. We're here at Open Source where a whole bunch of nerds show off all the cool projects they've been working on, and today we're here with...
Hi, I'm Nomad, I'm Positron. So this is Positron. It is the upside down 3D printer that fits inside a filament box. We designed this in college because we wanted to bring our 3D printer around, and we didn't want to lug an ender. So we decided, hey, why not design a 3D printer that fits inside a filament box?
Insane. And then when it folds up, do you lose tolerances or anything? Do you need to recalibrate it? Because 3D printers can be pretty finicky in that regard, right?
Yeah, so with everything here, I've traveled across the country, across the world, and I've only leveled my bed like 3 times in all that traveling.
Can you show us how it deploys?
Sure. I'll have Smiska here do that. Yep, so yeah, basically the whole thing unfolds. We have spring tension in the back that makes sure everything stays within the correct tension for the entire system. And then there's just 2 screws that are used to actually attach the Z-axis to the actual rigidity of the mount. And then we have a thumb screw on the top here that, again, keeps everything nice and rigid.
Insane. And I noticed this printing upside down. Is that just a product of the design, or was that intentional for other reasons?
100% a product of the design. We had to move the entire motion system kinematics into the base of the machine in order to get it to fit within a filament box. There is some advantages. So, of course, this is one of our prints that we did. And gravity works in weird ways. You still need supports because you can't print in midair.
Of course.
But we have noticed that you need just a little bit less.
Yeah. Because
the actual extrusion force of the printer can help in aiding with the printing process.
Super sick. And are these something you could buy, or are they a DIY kit?
So you can get a kit from KB3D, West 3D, and Fabrico here in the States. We have on our website, positron3d.com, we have a list of all retailers that currently have kits available.
Incredible. And then you, as the man who built it yourself, what was the hardest engineering problem on this thing that kept you up at night trying to make it work?
Honestly, getting the extruder to work efficiently was quite difficult, including making sure that it could fold down. So we worked with LDO, and we created a custom orbital style extruder and that allows us to ensure everything is nice and contained and print really reliably.
Normally it's a very tall piece that
Yeah.
sits vertically and right.
And the other fun challenge was making sure the nozzle worked. So we have actually a nozzle right here, and you can see it's a 90-degree nozzle. We
And
worked
having
originally.
the filament bend up the
Yeah.
tube probably isn't trivial.
So it is
Yeah.
actually just a machine piece. So we actually just drill in that way and that way, and it's just a right angle.
So cool. And if anybody wants to learn more, where can they find info about you guys and your project?
You guys can go to positron3d.com, and you can find more about it there, as well as our Discord and future projects such as Crucial Wire.